thank you very much for the kind introduction. Okay, I hope now everybody can hear. So yeah, we're going to change topic a bit, talk about quantum sensing, talk about QNAMI. We've been one of the pioneers in that field, working since 2017, as was already said before. Our team has now reached about 25 people. We're backed up by venture capital, but also generating revenue already, so happy to report that we're actually meeting end-user real use case. My name is Mathieu Munch. I'm the co-founder and CEO of QNAMI. And to start with, I'd like to explain a little about this market that we're after. So we've looked into sensing, and we've looked in particular into sensing use cases where there is today a strong demand for high precision or high sensitivity. It's the two sides of the same coin. And we've looked at that with the help of the Boston Consulting Group, and we can identify a pool of use case which will represent a 25 to 40 billion market opportunity by 2030. What that means is that this is a pool, a value pool, where quantum sensors are meant to play a growing role because of their intrinsic capabilities to deliver on higher performance. In terms of just quick examples, where is that sensitivity needed? Semiconductor industry, for example, we're going to say a word about it in a second. The idea here is that the current trends in miniaturization are putting the manufacturing costs or the process development cost up to the roof, are posing a challenge on yield, and ideally getting information at the level where single cells are being built today is what is needed to enable a transition in that industry. A second example is in the medical space. Here, of course, you know that if you could diagnose with better precision, you would be able to first make earlier diagnostics, but also, when surgery is needed, have a much more targeted approach. The platform that we're working on are NV centers in diamond. You might have heard of them today, and they're pretty prominent in the show. Why do we like them? We like them because they are a quantum system, so they provide this atomic precision, if you like. They are operating at room temperature, which is a key ingredient for sensor application in particular, because you want them implemented on the field and not just in a data center. And last, but maybe most importantly, this technology is in the range of is in the semiconductor family. So there is a very clear path forwards on how you can miniaturize, scale down, and scale in terms of cost, and scale up in terms of volume, that type of sensor technology. Now, with any new technology, there is a lot to do, and there is a full ecosystem to develop, right? So our part, the work we've done so far in the past years, has been to develop end-to-end solution, starting with raw material, like the very high-quality diamond that we need in the first place, and developing a full solution to meet our customer needs. Roughly speaking, we're talking about two main areas. One is what we like to call the quantum foundry, where we do all the nanofabrication, packaging, so that we end up with compact finished devices. And the other side of things is the integration in the customer workflow. And we're talking here about integrating these sensors in a system, and also data management to meet the actual need from the user. So this is our product portfolio. In the first years, we focused on microscopy, and this is the product that you see on the left, on your left. So what we have here is a quantum sensors that have been engineered to fit into a commercial microscope and provide a boost in terms of sensitivity. Who asked for that? Well, the semiconductor industry, and in particular, engineers and scientists developing the next generation chips. and they want this further insight that I already mentioned. I will say a few more words about it in the use case explanation in the next slide. We're currently building a pilot of that based on that same technology for cryogenic application. The idea here is that we want to support not only the semiconductor industry in their chip development, but also the quantum industry in their quantum chip development, so inspection of superconducting materials, for example. So that's a pilot we're building with the Technical University of Munich. And finally, on the right side, you have what we call the Quantum Foundry, which I already introduced, which we have offered as a service for already a number of years. What we do here is we provide early adopters in the quantum sensing area with manufacturing capabilities that they would otherwise need to invest in just to build the first pilot, to build the first instrument, to build the first understanding of what that type of technology can do for them. So this is a service they can come to us and we co-engineer, co-design with them with the manufacturing capabilities later on if it's interesting to them. A few words about this use case, because I think use cases are important in the quantum industry. We want to understand where we're actually already making a difference. So here, what the sensor does, it really measures magnetic signals at the nanometer level. So this is the single unit cell level. So this picture, which is behind me, is coming from a use case that we've published earlier this year with our partner IMEC. It's the big R&D house for semiconductor, where you can see dots. All these dots are a bit pointing in a certain direction. All the black regions are dots pointing in the other direction. From this type of knowledge, the process engineers are able to tell where the faulty bits come from, what is working in the process, what is not. They're able to inform the system architecture as well, because ultimately you will have error code implementation. So bottom line, this helps them to reduce the development time by about 30%, which is a huge number. And why is this so important to them? You have heard about AI, I'm sure. You probably also know that the huge amount of work in AI now is also actually representing a challenge for the underlying hardware, right? AI is very consuming in terms of memory capacity, but also in terms of pure power consumption, right? So these industry, the semiconductor industry, is looking for the next memory that will be very dense, very low energy, and MRAM is one of these examples, so that's what our first use case was about. If you want to know a little more about it, our director of product is giving a more focused talk about that in the QBN Industry Summit, which is somewhere around. And before I conclude, I'd like to say that QNAMI is also interested in other problems where we see that we can bring the value that we have developed so far. And as an example, I'd like to talk about brain imaging, which may sound quite disconnected, but actually bears a lot of similar features. We're talking about some sort of electronic circuit, which is not on a chip this time, but in your brain, right? So it's clear that the sensor solution is going to look pretty different at the end. But to give you two concrete examples where our expertise is already important, on the one end, to do very good sensors, which is needed in both cases, you need to optimize one quantity, which we call photon extraction efficiency. So it's light collection in simple terms, right? So we have developed designs, but also manufacturing processes that allow us to preserve the quality of our quantum sensors and optimize that property, and we want to recycle that. The second thing is at the complete other extreme. That's another use case we've published earlier this year in terms of data management. The semiconductor industry, in the measurement that we do, we have a certain magnetic field at a certain location where our sensor is. But what we're really interested in is to understand where the source of the signal is, right? And that is the same question in the brain. You want to understand where a potential location for epileptic seizure is with great accuracy. So we have developed a machine learning algorithm which takes the data and calculates back where the source signal is, Now it works in 2D, that's what we needed, and we're moving into 3D, which is needed for brain imaging. So these are just two examples why the platform that we developed can address a number of different examples. And we're, of course, extremely curious to hear from you in the audience, from the industries around, what are your needs and whether we can help develop and support the ecosystem going in this direction. So with this, I'm finished. I'd like to say as well, if there are some investors in the room, we never know, that you can contact me to get more information about our next financing round. And also always the words for talents, young, seniors, engineering, business. We're having, I think, 3 open positions right now, and there will be even a lot more in 24. So please also connect with us. We have a booth over there. I'm here the whole afternoon. And with this, thank you for your attention, and maybe enjoy your lunch now.